Alright, grade 11s. We're going to go into simplifying rational polynomial expressions now that you guys have the ability to find the non-permissible values. So simplify RPEs. Yeah, we did the non-permissible values in grade, well, the same skill in grade 10 when we solved by factoring. We did use it in the inequalities when we found the asymptotes or the critical points, however you want to call them for the assignment B. So now that we know how to do the NPVs, we'll simplify RPs. And remember, when we say simplify, we really mean factor and cancel. So get used to that, because that is the main thing of this unit. So this is just the start, the factoring and canceling, okay, of all rational polynomial expressions. So let's just do a real quick example. Now, remember, for this entire unit, every time you see an RPE, which is any polynomial that's in a fraction form, you have to find the non-permissible values. But for these examples, I'm not going to go and find the NPVs. I'll mention them, or I'll maybe review how to find them and stuff like that, but we're not going to worry about them too much. So if we start with a simple example like 2x squared over x. There's nothing in this rational polynomial expression to factor, so to speak, but we can cancel things. And you guys can see that the 2 divided by a 1 is just equal to 2. Nothing big about that. But I can also cancel one x in the bottom with one of these x's up top and be left with 2x. It's really just 2x squared divided by 2x. Nice and simple. Well, let's get a little bit crazy here. Let's go with 3x plus 3 all over a 3. Well, if we think we're simplifying rational polynomial expressions, and that really means to factor and cancel, I'm going to GCF, greatest common factor, a 3 out of the top, so I'll be left with 3 times x plus 1 all over 3. Now, I hope you can see that we can cancel the 3. And we did see something like this in the inequality stuff when we were first solving. Well, I guess I don't need the brackets around that anymore. When we were first solving inequalities, rational polynomial inequalities, okay? We'll get a little bit crazier as we go along here. Now, the one thing that I got to say that you got to keep in mind here is this. We'll do some steps, but you can never cancel if there's an addition subtraction between two factors, because they're not factors then. Factors are things that are separated by multiplication. Okay, so we'll get to some examples and I'll point that out. But the step 1 is simply always find the NPVs. So ignoring that, we'll go to step 2 here. Factor everything. And lots of people would say do your NPVs after. And I kind of agree with this too. Factor everything as far as possible. So some people will find their non-permissible values after they do the first 2 steps. 2, cancel any like factors. Okay, and by cancel, I mean divide them out so that they equal 1. And then 3 would be your find NPVs, but like I said, you can do that start. So that's the only 2 steps again. So a real quick example of this might be something like this. X minus 5 over x squared minus 25. Now, here's what I'm talking about. Lots of people will make the mistake of reducing this and then this. Well, that's not right, okay? What you have to do is you actually have to factor. So if we go back here now, the top x minus 5 is factored as far as it can be. There's nothing more you can do with that, let's be honest. But on the bottom, x squared subtract 25, well, that's a difference of squares. So if I factor that out, I get x minus 5 times x plus 5. And when I cancel that out, I get x minus 5, canceling with an x minus 5, because this factor up top and this factor down bottom are exactly the same. So I can cancel them out, and I'm left with 1 over x plus 5. Capiche? I hope so. So, let's get a little bit more wild. I'm trying to think here of a trinomial one. We got 2x squared plus 5x plus 2 all over x squared plus 3x plus 2. So you've got a trinomial difficult, and you've got a trinomial easy. So if we're asked to simplify that, I mean, okay, yeah, NPVs, go ahead, find them. It's x squared plus 3x plus 2 cannot equal 0. Factor that, solve it. That's one thing. But if we just go ahead and factor this. So I'm going to do the trinomial difficult first. Okay? So what times what gives me a 4 that adds to give me a 5? Well, 4 and 1 work. 4 and 1 work. So that one there, take care. I'm going to put in, so 2x squared. This is for those of you who forget how to trinomial difficult factor. Put my splitter in place, right? 1x and then plus 2. Okay, I got a GCF out of the bracket, so I can GCF a 2x out of this first bracket. I'm left with x plus 2. I'll GCF a 1 out of the second bracket. Okay, and now I can group everything up. So x plus 2, 2x plus 1. Okay, so that's the trinomial difficult. So I'm going to put that in place. X plus 2 and 2x plus 1. The nice thing is, if this factoring, I mean, outside of your tests and stuff like that, you can do that on scrap paper, because really that's not the important part. The important part is what the result is. Okay, that's the trinomial difficult taken care of. Now I'll do the trinomial easy. I'll do the trinomial easy. I'll try and squeeze it in over here. What times what gives me a 2 that adds to give me a 3? I believe that's a 2 and a 1. So there's our trinomial easy. And of course, we don't really have to show any work with the trinomial easy. It's just x plus 2, x plus 1. Perfect. Well, now, again, you can see that your factors are separated by a multiply. So I can cancel. And same thing here. They have to be identical, top and bottom. Okay? So I got an x plus 2 that'll cancel with an x plus 2 in the bottom. So I'm left over with a 2x plus 1 over an x plus 1. Now I've got nobody to ask me the question, well, why can't you cancel those 1s? Or why can't you cancel those x's? These ones and these ones. Because there's an addition in there. So that means that the x plus 1 and the 2x plus 1 are actually together as an entire factor. And you cannot, I say again, cancel factors unless they are exactly the same. So this 2x plus 1 we've got here is not the same as the x plus 1 on the bottom. But that's as simplified as that gets. Okay? Let's see if we can squeeze in one more big ugly one. I'm going to look, see if I can't cheat out a good one. I see there's a couple on your assignments here. I'll go down here to actually number 18. C minus D. This is number 18 from your assignments. 3t plus 3c all over 2c plus t, or sorry, 2t all over d minus c. Now, here's my warning. Sometimes things can get pretty fishy in here. And by that, I'm saying look very similar, but you have to do some things to make them the same. So, in this whole thing, I'm going to factor everything. Okay, well, let's look at this. This C minus D is factored completely. So, let's write it down. C minus D. Okay, perfect. This 3T plus 3C, I'm going to have to GCF. Well, I'm going to take out a 3. And I'm left over with a T plus a C in there. Okay, that's all right. Now, on the bottom, I've got a GCF of a 2, so that becomes C plus T. That's okay. And this D minus C. Okay. I hope you can see how things are fishy here. We've got things that look very similar, but are different, yet the same. Well, let's take T plus C and C plus T, for instance. They look the same, but are they same? Well, let's do some figuring here. T equals, let's pick a number, let's go with 2. And let's say C is equal to 5. Just for fun here. Well, if we said 2 plus 5, I think we get 7. And if we flip that around and go 5 plus 2, we still get 7. So, okay, those are obviously identical. When we add things, they're identical. Just because they're in different spots, that's okay. So we can actually cancel the T plus C and the C plus T. Okay? Using that same idea of the substituting numbers. Well, now, we've got another small issue here. We've got a D minus C and a C minus D here. Okay, well, let's try and figure this one out. Well, let's assume that C equals 5 and D equals 4. Okay, well, 5 subtract 4 is equal to 1 up top. If we were to actually have numbers in there. But now, let's look at the bottom. Let's see if it gives us the same answer. Well, 4 subtract 5, that equals a negative 1. So it's not the same, but you'll notice the number, the magnitude of it is. So if I just factor out a negative, so right now I'm going to just go down, I'm going to not skip a step. I'm going to have C minus D over top of 2 D minus C. Okay, that 3 out front just comes from one of the GCF we took out earlier in the middle. Okay, so it's nothing new. All right, so I'm going to erase this because I'm going to use this space. If we look at C minus D or D minus C, it doesn't matter which one we factor a negative 1 out. But if I factor a negative 1 out of this, a GCF of negative 1, I'm going to take it out. I get up here, I end up with a negative 3. When I factor a negative 1 out of that, that becomes a negative C and a plus D in the numerator. Over, we haven't touched the bottom yet, so 2 over D minus C. Now you can see that the numerator and the denominator, that the variables have the same sign. It's now a negative C and a positive D, and in the denominator it's also a positive D and a negative C. So that means they're identical. So we can cancel them out, and we're left with negative 3 halves. Perfect. Okay? So I hope you can see that if they're fishy, and by fishy I mean the same variables separated with a subtraction on opposite sides, like you can see the C minus D and the D minus C. Okay? I'm going to do maybe just one simple example where we don't have to factor anything out for those. So a real simple one might be this. X minus 2 over a 2 minus x. Now that's fishy because it's the exact same terms, x and a 2, in different positions in the numerator compared to the denominator, separated by a negative. Well, if I factor out a negative 1 out of the numerator or the denominator, it doesn't matter which one you do it to, but pick one. that becomes a negative x and a positive 2 over a 2 minus x. Okay, well now just so you can see it, I'll rearrange the numerator. It's still a negative, but I'll move the 2 to the front, it's positive, and it's a negative x over 2 minus x. Well now, these factors would cancel, and I'd be left with a negative 1. So that, oh boy, that's real nice. So, my pen has gone awry, and I'm going to write the rest of it out for you. Let's try this again. Factor out a negative 1, and I end up with a negative x plus a 2 over 2 minus x. And when I do that, I'll rearrange it and move the 2 to the front. It's a negative x all over 2 minus x. And again, our factors, like I said earlier, are the same. They cancel out. We're left with a negative 1. Perfect.